So, we're a bit late, so I need to hurry up a bit. I have a lot of stuff to cover. And I know we had a bunch of topics today already, a lot of interesting stuff. So my name is Tim, and I'm the CTO and founder of Stellate. We build production-grade GraphQL tooling, currently focusing on edge caching. And so I've been in the GraphQL ecosystem for a while, started using it in 2016, and since then built a bunch of GraphQL production systems. And there are a lot of ways to make your API fast. And not just your API, but the whole GraphQL system. And I wanted today just share my learnings with you and some things that might be helpful for you as well. So today we will talk about how to make GraphQL blazingly fast. So the question is, how do I get to the next slide? I hope we're not stuck here. Ah, yeah, there we go. Ah, perfect. So what does it even mean to say blazingly fast? I mean, for that, we should first define the use case. For whom do we want to make it blazingly fast? Am I a user of a web app, maybe user of a mobile app, or am I a build script? Who am I? If we ask Eckhart Tolle, you would say, I'm the observer of my thoughts. But well, that's not very helpful in this context. Before we dive deep into this rabbit hole of performance, I want to just say maybe working on performance is not the most important thing in that moment in your business. Maybe building a feature could be more important. So when you watch this talk online, maybe you want to press pause and check. Here, locally, we will just dive into the rabbit hole now. So what does blazingly fast mean? I think I like the definition of Google research where they say that if you flip a page on a website, doing that in 100 milliseconds, that is considered blazingly fast, meaning it's considered instant. Anything that is more like 10 seconds, you will just lose users, even though you might have a great application and great content. So, but isn't GraphQL blazingly fast? I mean, that's one reason we use it, right? Well, if you look in all the libraries, they will say, yes, they are blazingly fast, and it seems like you just need to choose the right library and you're done with the job. The reality looks a bit different. There are a bunch of people struggling online, Reddit forums, etc., saying that they can't make it blazingly fast and they don't know how. And so today, I want to give you some principles, first principles, so that you can make your GraphQL system blazingly fast. And we will start actually with 3 main tricks, and then we dive deeper into what I exactly mean. Number 1 is you need to measure. You might not know, but you have some performance bottleneck somewhere that is really huge, and before starting any performance optimization, please measure. Once you're measured and you know where the culprit is, what is slow in my whole system, the next step is to measure again. You know now that maybe your change improved something or maybe not, and then you measure again. So these are my 3 main points, and the talk is over. No. So of course more than that. Before diving into actual points now, what you can do, let's talk some numbers. Jeff Dean, smart guy from Google, he came up with these numbers, and they apply to basically every web app or distributed system. And the TLDR of these numbers is memory is fast, network is slow. Not a surprise, but we will come back to that later and use that insight, the simple insight, network is slow, memory fast, to make our apps fast as well. So how can we measure? We'll go into load testing, tracing, and performance testing. So for load testing, a nice tool is Artillery. You can install it as an NPM package, and they have like a YAML syntax, and you can fairly easily write GraphQL tests. Here we're sending a Pokemon query, for example. So you get these nice reports, and you know how your system works under load, can run it locally, but also in the cloud. For tracing, in my opinion, in 2022, you should use OpenTelemetry. OpenTelemetry is a standard that has been established recently by a bunch of APM providers like Datadog, Honeycomb, and so on. They realized it's not very helpful if everyone has their own proprietary standard, so they agreed on one standard together. So OpenTelemetry is, in my opinion, the way to go. And now, how can you do that in GraphQL? It's still a fairly new topic. The libraries are still establishing themselves, and there's just a handful of good solutions. I want to quickly talk about Pothos and Zipkin. I'm a bit biased here because the Pothos creator works at Stellate, But the idea is basically that I can connect both those with any OpenTelemetry provider. In this case, I'm using Zipkin, which is an open source OpenTelemetry sync basically, and I can just run it locally. In production, I would probably use something like Honeycomb. And so how does this help me now? A use case that we have oftentimes is that a GraphQL query resolves as fast as the slowest field. So if there's a field that takes 5 seconds, even though all other fields maybe took just 2 milliseconds, doesn't matter. And just finding that out and finding out why that field is slow, that is something that OpenTelemetry can tell you. Here's a screenshot from the Zipkin UI, and we see, surprise, surprise, if we delay by 3 seconds, it's slower. Obviously, in practice, it's usually not that easy, but this is just to show you how it can look like. And then the third topic around measuring is actually locally on your machine and testing the performance. So I'm a big fan of the library bema. It's built by an ex-colleague of mine at Prisma, Jason Kurt. It's basically, if you can say, jest for benchmarking. And you can basically build your suite here, test 2 different variants of the same solution, and then you get this nice test output. So what I just want to say here is that there are a lot of libraries saying we are the fastest library, and they give you a very specific benchmark. They usually use these kind of tools that are locally. And it's important to note, tracing is really important, and also load testing. You cannot replace them. And even though you might use fast libraries, that's not all. You really need to test in production. And another really nice tool I like to use locally is Quokka. Who of you has heard of Quokka.js? A few people, maybe a third, I would say. So Quokka.js is a paid VS Code extension. I'm not paid by them, but I like it a lot. You can add little annotations here, as in line 25, 26, you see like the question mark dot syntax, and with that, you can directly inline see how long a function call takes. I really like that to try out quick ideas. So let's recap. We want to do load testing, tracing, and performance testing together. You can't just do one of them. If you just do the local performance testing, that's not enough to know how your production system will actually work. And as I said, benchmarks can lie, and if you torture data long enough, it will always confess to you. So now, what are the actual tricks? What are the actual ways how we can make GraphQL fast? As I said, it's very related, very individual to your server and to your client and so on, but I will focus on some more general topics today. So we will look into the server now and start with the general server architecture in terms of location of the server and the database. We'll talk about data gravity. We'll talk about caching, and then the general improvements I won't talk about because, again, it's very specific to your server, but you can use the benchmarking tools that I was mentioning earlier. So we want to look at this query here as a case study, probably a query you have seen a lot in examples. It's basically getting the posts and then the comments for that query, and how can we now do this efficiently? What are the different architectures we can use? Number one, old school. Not yet even using GraphQL, just REST. So we have 2 round trips here to the server. We first get all the posts with a get call, and then we would have actually more than 2 round trips. We would have 50 calls. I intentionally made the most inefficient version here, where we would get all the individual comments. That's obviously not very efficient. We would have 51 API calls from the client to the server. With GraphQL, we can push all of this to the server, which is still much more efficient, but it's also not yet solving anything if the server and the database have a big distance. And for some of you, that might be totally trivial, but having been in the GraphQL forums and chats for a while, I still see it over and over. People complain, my server is slow. Okay, where's your server? Where's your database? So just moving the server and the database in the same data center or same region helps a lot. Pay attention on that. We still have this call that is happening 50 times. And some people here might already know the solution for this. Okay, data loader. So with data loader, so all of these queries here basically look the same. We're always saying, give me the comment with a certain ID. And now we can use an in query here. And so how this actually looks like is that we are basically merging all of these SQL queries together. And that way, you can imagine it's faster to send less queries to the SQL database. And I did a talk about it 2020 at Prisma Day, how it works. You can watch that. There's one more topic I want to mention here, which is people, there's a lot of stuff happening, moving GraphQL servers to the edge. It's great, just be careful. I talked about data gravity. You usually want to have your compute and data next to each other. So if you still have your database, let's say in Wrocław in Poland, and now you have edge compute, suddenly these round trips, because between your compute and your database will be slower, and your whole app will slow down. So this only makes sense to use the workers if your data source is also at the edge. There's one more topic, but I want to mention, use it with caution. It's query delegation. It's something that, for example, Hasura is using a technique where you basically turn the whole GraphQL query directly into an SQL statement. It's nice. Problem is that the guarantees that you usually have around your GraphQL execution in the server are not there anymore. So be careful. I shot myself in the foot with it. It's super tempting to use it because you save round trips. I usually recommend just using data loader instead, although this looks very tempting. And by the way, with Postgres, you can basically turn anything into just one big query. Okay, so we just said server and database in the same location because of data gravity. You want to move compute to the server, to the database, and data loader should just be activated by default. By the way, this case where we just have these 5 queries and we turn it into 1, that's called the n+1 problem. So let's have a look at caching. It turns out that I'm actually a founder of a caching company, but I want to tell you when not to use it, because caching can be complicated. It can make a really big impact on your performance, but sometimes it's not worth it. So when is it not worth it? It's not worth it when you have a low amount of users, it's write heavy, very personalized data, or you have one-off queries. So basically when you can't have a high cache hit rate, it's not that useful. And if you, for example, have a dashboard that only 3 people open, maybe you don't want to implement it. Where caching is very useful, for example, if you have a high amount of users, a lot of read heavy, so most of the actual GraphQL requests are queries. And then if you have shared data, then it's very valuable. So examples are e-commerce. I mean, we have the Celia people here. They know why that makes a difference. If you have a critical business path that can be made faster by this, then it's really useful, generally as a rule, and some other use cases that we also see after operating Stellate for over a year now. So you need to decide it for yourself. This is not a rule, it's just a direction that you should take into consideration when you ask yourself if caching is something for you or not. So let's say caching is something for you. And by the way, when I talk about caching, I talk about server-side caching. Client-side caching is still a different beast. I like to see it as full-stack caching, by the way. You can cache it in many different layers. We will now mostly focus on client and edge. So the caching itself is trivial. What is not trivial is the invalidation, and that's something we want to go into now. There are 3 main categories how you can invalidate the cache. And by the way, just quick terms here: purging, invalidating, cache busting, it's all the same. It's just different words for the same thing. Let's start with time-to-live-based cache invalidation. So the cache control header, HTTP header, is pretty awesome. It has the max age, which just says you can store it for a minute or an hour. And then it has a feature called stale while revalidate. Who of you knows the SWR library from Vercel? Oh, okay. Just 2 people. So there's a library called SWR, short for stale while revalidate. And the idea is really that while this request comes in, let's say after 120 seconds in this scenario, we are refetching the original data. So it's kind of lazily fetching the data when someone requests the data, and we return the actual stale data with that. So that's a pretty smart algorithm. Mutation-based invalidation, this is an example in Oracle. Again, I'm a bit biased because the Oracle creators work at Stellate, but the idea is basically you can do it as well in Relay or Apollo client. I have a mutation, and with that mutation, I now change the local state in the client. And then last but not least, you can have invalidation based on the schema. So if I say, I have a mission here, this is, I think, the SpaceX API. I want to invalidate all the stored queries that have the mission with ID 1. So that's something we, for example, provide with Stellate. Okay, so recap, we have all of these different mechanisms, and I recommend having a look in Urkel. Urkel has really strong documentation around how the normalized cache and everything works. And, well, we're doing caching full-time at Starlate, so you can also have a look there. And so just to recap all the server work here, we want to first measure, make sure that we have the base architecture in a good shape, make sure we don't have n+1 problems, and then if caching makes sense, can use it, doesn't make sense in all cases, and then we can later look into more fine-grained performance tuning, for example, using the fastest framework out there. That might actually not make the biggest difference. Okay, so let's move on to the actual problem today, which is perception. So why we do all of this is that actually we want to delight our users. Performance is a feature. And so how can we work on that? I think the perception is a lot driven by the client, and there's a lot we can do. We can use fast frameworks like Next.js, and there's a lot of work with the Web Vitals and Lighthouse scores and so on. But I will focus on the GraphQL-related parts today and the mechanisms we can use in clients and how to use them. So in Urkel, we can use so-called optimistic UI updates. The idea is really that if I already know what the mutation will return, why don't I already pretend as if the mutation returns so my UI can move on and I don't need to wait a few seconds until the page reloads. So here we are mocking basically, we guess the return type, return response of the backend. Normalized caching is a powerful technique. It is also sometimes a bit, let's say, scary. So that's why it's not set up by default in clients like Urkel. It can have certain edge cases. Generally, it's very powerful. Relay is based on normalized caching, and Facebook uses it very successfully. So there are great use cases for it. I would try it out. Setting it up is easy, but trying it out, you might have some edge cases that you need to invalidate properly. Always just refetching from the server won't have these cases, but will also not be as fast, of course. And then there's a new kid on the block, which is also already a bit old, stream and defer. In web development, there's the idea of the fold. So basically anything you see in the initial screen when you load a page, and usually you want to first just load that content, and everything else you want to prioritize lower. And one way to do that on the data level is using stream and defer. So it's a way to prioritize data. Sometimes you know that some data is quite heavy, but as we said, currently the whole GraphQL query needs to wait for all the data. So to speed that up, you can apply the @defer directive to the data that you say, I need it later, maybe when you scroll down the page. So in this case, we say that we want to have the name of the person, but the home world, I think it's the Star Wars API, in the home world would be fetched later, and so the payloads are really kind of patches that are coming in step by step. And by the way, this is not yet production ready. Rob Richard is the champion for this. So in a GraphQL working group, you always have a champion who pushes a topic forward, and that can take years, and he's on this for years already. It's in a pretty good state. It's still a topic of discussion in the working group. They're currently talking about batching stream responses. We might hear more about it later. Okay, whoa, we just covered a lot. And I just want to cover one more thing. Coming back to Jeff Dean's numbers. So we said it's quite simple. It's clear to everyone, if you directly access something from memory, it's much faster. Just saving the network request. And so how could we achieve that? How about we just skip the web server? How about we, instead of saying we go with the web server first, we go with local storage first, instead of local storage just being a cache? And that's actually a movement that is happening right now. It's called the local first. Who has heard about local first? Whoa, okay, 4 people in the room, so interesting. Let's see in a year how many people have heard about it. So the idea really is simple. You store all the data first locally. The user owns all the data. SQLite is very popular for these solutions. Does that make GraphQL obsolete? I don't think so. You still need to sync all of this data, but this is just an interesting approach that just popped up a few years ago and is now becoming more and more popular. There is one library called think Aphrodite, if I pronounce correctly. Riffle is a research project that also a friend of mine, Johannes, who is later in the discussion, works on, and he also did a great talk a few weeks ago just to focus on this topic. Local first is really interesting. Doesn't cover all the use cases, but if you think, for example, about a Notion, some of you might have realized that sometimes it takes a while for things to load in Notion. It's really nice. It's a really interesting approach, and I think we will see way more libraries over the next year in this space. Okay, well, we covered a lot, and I have no idea if we're over time, but I think so. Let's start with measuring always. On the server side, let's first make sure the basics are right, and then we dive into some crazy performance rabbit holes. On the client side, it's really all about perception. Want to make sure that we use the right tools. Optimistic UI updates, for example, are fairly low-hanging fruit usually. And then have a look at local first. Thanks, everyone.
Thank you, Tim. Great presentation, a lot of interesting stuff. It seems that your tool is solving one of the critique that I hear most often, like GraphQL. How do you do caching in GraphQL? And it seems that there is a solution for that already, which is very nice. So, do we have any questions?
So thanks of all, thanks for the presentation. It was super interesting. And my question is, what's the main difference between offline first and local first? Is it because we are using defer to gather all of the data from the services and to cache it on, for example, mobile device, and just to perform updates locally and later to stream it to server, or how does it work?
I'm not familiar with what offline first really means, but I would say the following. I think it's more about who owns the data. And in the local first, it's really that the device owns the data, and the server is more just for backup. So whereas normally in a normal web app, the server owns the data and the device might cache it a bit, it's turned around. So rather the server is for backup, but the device owns the data, means if the device is gone, the data is gone.
All right, thanks.
Unless you did a backup, yeah. But I'm not an expert on local first, so you want to probably ask Johannes about it later.
All right, one more.
Why did they make this defer directive instead of just splitting the query? What is the advantage?
It's basically syntactic sugar. So you could indeed split queries, and we do that quite a bit in our analytics dashboard at Stellate, but it is getting a bit ugly, and it's nice to have this within the language. It's also very useful for stream, so when you just have, let's say, a few thousands of rows that you want to stream in, but you want to already show something, you might just need 20 to show the initial. Stream is also quite powerful for that. It's basically making it easier. You could also do it with separate queries, yes.
Won't it break a lot of software, like GraphQL code generator, for example?
Why?
Because then the payload is splitted to two different results.
Yeah. What you have is that basically everything that can be streamed is nullable. So that's why you as a client need to say, if you say add defer or stream. You could also say that the server knows themselves if something is slow. And that's, by the way, also a point of discussion in the working group. Should the server be able to ignore the add defer? So if the server says, I have all the data, I just give it over to you. And I think the answer is yes, currently. But it's more like the client says, I don't need the data right now. If you are busy with it, give it to me later. And with that, it's basically nullable, although it might be a required field.
Thank you.
Yeah.
Okay, maybe we can have one more question.
At what level the defer annotation is planned to be added? Is it at the specification level or library?
So it's already implemented in GraphQL JS. There's a PR open for it. You can try it out. I know that the C# implementation has it. So there are these... I currently don't know the stage of it. You can look it up on the working group repository.
Okay,
yeah.
Thanks.
Yep.
Okay, thanks a lot, Tim. So one more round of applause for Tim.